Okay, good morning everybody. So this is, I forgot about the attendance. So I think you know about the enumerations in C, right? You know about the enumerations? Could you open that door? Yes or no? You know enumerations? Yes. Is that a yes? Yes. Okay. C++ makes the enumerations a little bit more stronger because in C enumerations are just simple integer assignments, constant integer assignments. When you make an enumeration, it starts from 0 and it increases up to some number, and you can define your constant number for the enumerations. In C++, there is a new enumeration type, strong enumeration, strong enums or enum classes. It doesn't act like an integer, and it is defined like this. Let's say I have an enumeration of days of the week, and in that case, I have this line, Sunday to Saturday, and I have another enumeration, weather, rainy or sunny, okay? And after I declare these two enumeration types, now I have a type named days, and I have another type named weather, okay? It's like a new type, okay? Very limited type. All I can do is I can make an assignment. I can make an assignment of these type objects. D can have this value. W can have this value, but these are not integers. I mean, I cannot say if D is 0 or increment D or etc. Okay. All I can do is compare D against these enumeration values. If D is a Wednesday, or if W is a sunny day, etc. Okay, so this one is illegal. This one is illegal. Okay, here, but this one is legal. So it's a new enumeration type. If you need to use enumerations, use the C++ 11 strong enumerations, not C enumerations. Okay. Okay, good. So as we said, if there is something new in C++ that comes with C++ 11, not 98, we will tell you, and that's what we are doing right now. Good. What was the name of this chapter? This chapter is about control structures, right? The loops, branching structures, and etc. So let's look at the control structures, branching structures. If, as we know it in C, it exists in C++, and there is no difference. It just needs a Boolean expression here, between the parentheses, a Boolean expression. Okay. Well, I mean, integer, non-integer works for the if statements, but we don't prefer it in C++. We prefer the Booleans. So there is a Boolean expression here. Ours is greater than 40, then I do this assignment, otherwise I do this assignment. So it's a branching mechanism, and it is exactly the same as C. So I won't talk about much. Some people are confused between assignment operator and the equality operator. Okay, this one produces a Boolean. This one returns the value assigned, and their jobs are very different. This one has a side effect. Okay, when you say A gets the value of B, okay, this statement has a side effect. What is the side effect? First of all, this one returns the value of B. Also, this one changes the value of A. It makes an assignment to A. It has a side effect. But this one doesn't have a side effect. It just returns true or false depending on the values of A and B. Okay. So this one kind of a sneaky operator. Again, sneaky operator. What do I mean by that? Usually you expect the operators or the functions, like when you say A plus B, it takes two parameters, it does something and it returns your result. This one behaves like that, this one behaves like that, but this one doesn't behave like that. It returns something, but before returning, okay, it changes the value of this variable. So when you write a function like this, f a comma b, you don't expect the values of a and b changed, right? This function takes two parameters and returns, let's say, an integer. It returns an integer. So it's a very nicely written function, you would say. This one is not. This one has a side effect. But without having those kind of side effects, I cannot do the assignment. So that's how it's going to be. So be careful about assignments. They are very different. And unfortunately, the compiler will not give you an error message for this kind of a logical error. You see the error, right? So instead of, some people, they forgot about this equality sign, right? Instead of using equality, they used assignment operator. So this will work, and this will always do something, right? Because 12 is always non-zero. It will go into this one, and it will do this assignment. And if you are doing this on purpose, if this is your intention of doing this, this is a very wrong way of coding. You shouldn't do you shouldn't write such statements in C or C++ or anywhere, because it is simply confusing. I mean, the reader wouldn't know if you did this on purpose or if it is by accident, okay? So if your intention is making this assignment, do it separately. Don't do it in an if statement. Most of the time, this is a logical error, and don't do this. That's why some people, when they are doing the equality operator, some people prefers, instead of writing if x is equal to 12, they write it this way. Okay. So if I forget about one of the equal signs, it becomes this, and this is an error message, right? I cannot assign x to 12. Okay. So remember, and I suggest you do the same thing. Okay. Prefer this mechanism, and this will tell the reader that it is your intention to compare 12 with x. Okay, that's your intention. You didn't do it by mistake or anything like that. And if you make a mistake, you will get the error from the compiler. Always try to write code. Okay, always try to write code that makes use of the compiler's error and warning messages. If you forget something, then you should get some kind of error from the compiler. This one doesn't have any hope. Well, I think there is a option in G++ that would produce a warning message for this, not the error, but the warning message. Are you sure you want to do that? Okay. Okay, are we done? Did everybody sign? Good. Okay, nested statements, like I said before, nested statement is part of the C language because we are doing structured programming here. Remember the if statements? Okay, the if statement is like this. There is a question here. What? Okay, is this equal to that one? Then I have two statement boxes. Okay, and then my execution continues. Okay, but in one of these boxes, of course, I can put another if statement, right? If true, do this. If false, then do this, and continue. So this is a nested statement. It's a nested statement. One nested statement at the upper level and one statement at the lower level, and I can go even one level further and write another if or while or some other statements in there. So this is possible because we are doing structured programming. This is part of the structured programming. Remember what we said at the beginning? We said that structured programming uses basically three things, okay? You, you stack your statements one after the other one, and each statement could be a nested statement, or you do your conditional if statement, or you do your loop, okay? So in any part of these statements, you can place any of these three structures as many times as you like. So it makes them nested. So it is possible to use these nested statements in C++ too, of course. That's the power of these kind of languages. And there is nothing confusing about it. If speed is greater than 55, then do this. Then the if part is another if part. If it is greater than 80, then do this, otherwise do this. So this else, of course, belongs to this if, right? Okay, you know about this. So proper indentation makes this code readable. Doesn't matter for the compiler if this else here or if that else is here, right? For the compiler, it doesn't matter. It is exactly the same thing. If you mess up with your indentation, okay? Indentation is for you, okay? Without the indentation, it is very difficult to read or write these kind of nested statements. So indentation is always important. Choosing proper identifier names, writing lots of meaningful comments, doing these kind of indentation, these are all good programming practices. Okay. Any questions so far? Any questions from the audience? Any questions from the audience? Online audience, I mean.
It's fine.
You are fine? Okay, good. Okay, well, I sometimes after the class I realize that some people are questions using the chat window. I mean, I don't have any intention of going and reading those questions. You have your microphone, right? Just ask the question using your microphone. And I don't have a chance to look at the questions either, okay? If you see somebody's asking a question, please ask it using your microphone by speaking up. Okay, multi-way if statement is possible, of course. I am not going to talk about it. You did this many times. Okay. Well, I mean, some people would say that if you are doing this kind of an if, then you should keep intending it, right? Because each if statement is a sub-statement of the if statement above. So maybe I should keep intending it more and more, but no, we don't do that. We do it this way. We do it this way. Because this if statement is a sub-statement of this if statement, so it should be intended to be. I am not going to intend it, because if I keep intending, it looks kind of weird. I don't want to do that. And so this is there is this custom of writing the multi-way if-else statements this way, and we are going to follow this custom, and this was already in C. Switch is another branching mechanism. Okay, if you are going to keep asking if the vehicle class is 1 or 2 or 3, if every time you are asking the same question and you are doing something accordingly, okay, instead of writing many if statements, some people say that why don't you write a switch statement, okay, and it exists in C and C++, and you should be very careful about these breaks. If you forget about the breaks, you are in trouble. I mean, if you need those breaks and if you forget about them, you are in trouble. And there is a default statement, you know that. Some programmers, they say that never use switch. It is difficult to use. It doesn't make your job easier. Just use if statements and etc. They might be right, but it is there, and it is part of the structured programming world. Okay. People structured programming, pure structured programmers, they don't like this statement of break. Okay, break, it just kind of violates the regular flow of programming, okay? Usually when you go into a box, you go out of the box and there is a flow. This one kind of like a go-to statement, right? Like a go-to statement. Well, it's kind of a controlled go-to statement. It doesn't go to anywhere you like. It just goes to the end of the box, switch box, but it is still kind of a go-to statement. They don't like it. But again, it is in C++. You are free to use it. Okay, forgetting the break, no compiler errors. We know that. Simply fall through. And you know these kind of problems, and the biggest case of breaks are the menus, and again I am not going to talk much about it. Ternary conditional operator is this one, okay? So what do we do? Compared N1 with N2. Actually these two are exactly the same, okay? I mean, I am not saying these are equivalent, I am saying these are exactly the same. This is doing exactly the same thing as if you look at the machine code. I think I tried it yesterday. Yeah, it is producing exactly the same assembly code. I hope it remembers it. Let me see if it is there. Yeah, no, okay. So this is the, I made it bigger so can you guys see it from the back? See it? Okay. So I have a conditional if statement here, preprocessor directive. Okay, it says if 0 do this, otherwise do this. It is the same code. Okay, if num is greater than 1, return 2, otherwise return 5. If num is greater than 1, so since this is 0, the compiler is compiling this part. Compiler doesn't see line number 4. Okay, so this line number 6 corresponds to line number 5 and 6. So I am comparing this stack memory position, okay, R base pointer minus 4 with 1, jump less than or equal to L2, okay. If it is less than or equal to 0, then you go to L2. L2 just returns 5. Otherwise, I am going to return 2. And L3 is the end of the function. So if I make this 1, the compiler is going to compile line number 4 and it will ignore 6, 7, 8. Just see what changes on the right side of your screen. You will see that nothing changes. Compile, then nothing has changed. Okay? Returns 2 or so. You say that all these lines 5, 6, 7, 8, 9, 10 are because of this. That's because these two statements are equivalent. So why do we need this? Sometimes this is clear enough, right? If number is greater than 1, return 2, otherwise 5. It is simple enough. But your if statement is complicated, it is doing lots of stuff, many stuff, then you shouldn't write these ternary conditional operators. Okay, only for very simple ifs. Okay, we use it a lot. If it is used properly, it could be useful. Good. Okay, loops, no changes. While loop, do while loop, and for loop, they are all there. No problems here. 3 types of loops in C++ and C. And I am not going to talk about it. Comma operator, we talk about it. Okay. Evaluates list of expression, return the value of the last one. So this one, this comma, okay, will evaluate this one first. Okay. Then it will evaluate the second part. And since this is an operator, it has to return something, right? What does it return? It returns the result of the second part. So what is the result of the second part? Assigned value. So you might say that, okay, this is not a very good statement because you are assuming that, okay, first is going to change and something is going to be added to first and it will be assigned to second. I don't know if this part is going to be done first or that part. No, comma guarantees that this part is going to be done first. So first will be assigned the number 2. Since first is 2 now, 2 plus 1 is 3. 3 will be assigned to second. So this comma will return what? Comma will return what does comma return? Comma will return the assigned value, which is 3. Okay, it will return 3, and first will assign the number of 3. Of course, don't write these kind of statements. I am just showing you this one for the sake of telling you what's happening here, because it is kind of confusing to read it and write it actually. But this what happens, and it doesn't depend on your compiler, it doesn't depend on your switches. Comma guarantees that the left side is going to be done first. It's like what other operator that guarantees the left side is going to be done first? Comma is the one that we learned today. What are the other ones that guarantee is the order of execution?
Or and AND.
Yes, logical or and logical AND. Not or and AND, logical or and logical AND. Because this one is an or and this one is an AND. What do we call this one? This is an or too. We call this bitwise or. Yeah, this one is bitwise or bitwise and logical or logical and. Okay, always know your terminology right and use it right. Okay, that will make your communication with the other programmers much more efficient. Okay, and that will eliminate lots of confusion. Okay, this one doesn't guarantee order of execution. This one doesn't guarantee it. But this one, and this one, and the Turner condition operator, of course. Okay, of course, the Turner condition operator definitely it takes 3 parameters, right? It definitely executes this one first, depending on the results, either this one or that one. Okay. So this is very tricky then. If A is greater than B, plus C, plus D. When you look at this statement, some people might say that C and D will always be incremented. No, it depends on the value of A and B, right? So sometimes this one is incremented, sometimes this one is incremented. But definitely this one is going to be done first. Okay, this one guarantees the order of execution too. So these four operators, okay, they guarantee the order of execution. Well, we use comma, we don't use comma for these kind of cases most of the time. So we use comma many times in the initialization section of the for loops, also the loop increment section of the for loops at the last part of the right, we separate them with the commas. But if it is possible to use this kind of stuff in other places, but as I said before, don't try to be creative when it comes to writing programs. Always write easy to understand, clear to understand, and easy to write code, so that your job later or somebody else's job later would be easier. Okay, we are not trying to come up with the most original program here. Okay, your application should be original. Your application should be very professionally written. They should look different. Yeah, that's true, but that doesn't mean that your programs itself should look different. Your program should look exactly the same as other people's programs. They should be easy to read. Okay, so don't try to make creative stuff like this one just because you know the rules of the C or C++ language. Always choose simple approaches when you are writing your programs. You won't be sorry. Okay, this is definitely a problem many of you fall into, putting a semicolon at the end of this while loop. Okay, no grammatical errors here, right? No grammatical errors. The compiler will compile this perfectly, no problem. So what is, so I think it's going to, most of the time it's going to run into some kind of a infinite loop, right? So this one says that if response is not 0, keep executing. So what am I going to execute? Nothing, right? I am not executing anything, so I am not changing the value of response. So I will keep running this loop, depending on the initial value of response, of course. And if the initial value is 0, then it will not run this loop at all. It will come into this block, and it will take one response, and it will continue without going into the loop. So if this is your intention, I mean, it might be the case where you want to do this while response is not 0. If you really want to do this, then do this. In a separate line, put your semicolon, and that will make your intention clearer to the reader that you definitely want this. You want something like an infinite loop here, okay? And you could do the same mistake with an if statement or the for statement too, okay? Okay, good. So you already know about this. Okay, sometimes you like infinite loops, like this one, while true. Okay, you want to print hello forever. Okay, you might say, what is the use for such a program? An infinite loop, there is no way to exit from this, but I mean, for some embedded systems, sometimes, or when you are doing the systems programming, for example, this is a very nice statement. Yeah, I mean, while my variable really is, I mean, my variable flag is 0, keep running this loop. We write this kind of loops very often in systems programming. So you might think that who is changing that flag? Isn't that program run forever? The answer is no, because we usually write multi-threaded or multi-process programs. There are more than one program running at the same time, and they have both access to this variable named flag, okay? One of them is waiting for flag to be non-zero. The other one is working on the other stuff. When the other program is done working, it makes flag 1, okay? Then this thread can continue. So it's kind of a way of communicating between two different threads or two different processes. Or sometimes this flag is connected to some kind of a hardware, for example, for your mouse, okay? When you click your mouse, your left button, this flag is made, okay, is assigned a value of, let's say, 5 by the hardware automatically. So your program will continue from that point, okay? So for embedded systems, for systems programming, for multiprocessing stuff, these kind of loops, you might see them often. Okay? Good. So infinite loops are possible. If it is your intention to write an infinite loop, write it this way, not this way. This is confusing. Okay? Break and continue statements in the for loops, while loops, okay, they are all possible. You know the breaks and continues. But again, we don't like them because these statements violate the natural flow of program execution, okay? They don't exactly agree with the rules of structured programming, because remember the structured programming, we don't like gotos. Breaks and continues are like gotos. So for a while loop, there is only one condition to exit. What is that condition? You write it at the top of the while loop, right? Or for the do while loop, I write that condition at the bottom. For the for loop, I know the condition is the middle statement in the for loop header. Okay, that's it. You may write other break and continue statements to change this flow of those loops, and that kind of makes it difficult to write those loops and difficult to read it. because you have to look for these keywords. Where else I am breaking this loop? Where else I am not continuing the rest of this loop, and etc. Okay, so don't use break and continue. If you feel that you have to use it, if you feel that you have to use this break and continue, then you are making a mistake. Okay, maybe you should design your program, your algorithm in a different way. Okay, these are all. I mean, you might say that it is easy to talk. Okay, when I am writing the programs, I am already in a very tense situation. I don't know what to do, and I am coming up with a nice algorithm, and it involves some breaks and continues and some go-tos, and you are telling me that I shouldn't do that. Yeah, that's what I am telling you, and if you really need to do that, well, do it first maybe, but later you come back, and when the program runs, write your program again without the breaks and continues. Okay? That will make definitely your program much more readable, and you realize that you made some mistakes. You take some logical error decisions. Nested loops, again, like the nested if statements with the structured programming, are possible. Outer loop, inner loop, and we know that. Okay. Usually, for an if statement or the while statement or for anything, if you have a single statement inside the loop or if statement, we don't use these curly brackets. Okay, don't use the curly brackets if they are not needed. That's the rule. Some people write it that way, but I don't like this kind of statements. When I read these kind of statements, I feel that they forget to put the second and the third statement inside this block. Why are they using these curly brackets here? Okay, if you have only a single statement inside this if or for loop, then don't use the curly brackets. Okay. Yes.
Doesn't it more readable when you use curly bracket?
No, it makes it less readable, because what does